Okay, hello all. So today we are going to study about automata theory. So what do you mean by automata theory? Okay, so before knowing about this automata theory, we have to know about automata. So automata means this is an abstract machine which means when we are giving the input to the abstract machine, some mathematical calculations is happening inside the abstract machine, which means the mathematical calculation. So when we are giving the input to the abstract machine, this abstract machine will do some mathematical calculation and it will produce the output. So this mathematical calculation is called as automata theory. Okay. Then next we will move on to the finite automata. Why we are saying this automata is finite means all the mathematical calculation should be finite. That's why we will call this automata is a finite automata. So in this finite automata we have 5 tuples, which means so here we are having the 5 tuples. M represents machine and Q represents the finite number of states. And this sigma represents the number of input symbols. And this delta symbol represents the transition function or mapping function. This transition function represents there is a transition between two states, which means if we are in the state of q naught, so we have to transit from q naught to q1, which means we have to move from one state to another state. That transition is called as this transition function. So we can represent this transition function as, so q is a number of states and q into sigma represents the input symbol. So which means when we are moving from one state to another state by using a input symbol, this is what called the transition function or mapping function. So this is called delta. Then next again we are having another one tuple, which means q naught. Q naught means initial state and F means final state. So these are the tuples, 5 tuples of finite automata. Now we will see the example of finite automata. So this diagram is called as transition diagram. So in this diagram, we are having these 5 tuples. For example, this one is called machine. So machine is called as this abstract machine. And here we are having the Q. Q means finite number of states. So in this transition diagram, we are having the states, which means Q0, Q1 and Q2. So these are the three states. And next one is sigma. Sigma represents the input symbol. So input symbol means we are to move from one state to another state, we should have something is called the input symbol. Okay, so this transition is done by using this input symbol. So in this transition diagram, we are having two input symbols, which means A comma B. And then next tuple is delta. So delta means transition function. So to represent this transition function, we have to represent the symbol, which means delta of. So here the transition function is, we are having, as I told, so here the transition is represented as the old state and the input symbol, we will move to the new state, right? So old state, input symbol, and we will reach the new state. So that here our state is Q naught and the input symbol is A. So we are in Q naught state, which means that this is the initial state, and we are reading the input symbol A, so that we will move on to the new state, which means Q1. So this is one transition function. And again, we are having another one transition, right? So here we can write that transition as transition function of, here we are having the old state is Q1. So Q1 comma, the input is B. So Q1 comma B. So we are in the state of Q1, and by reading the input symbol B, we will move on to the new state, which means Q2. So these two are transition function or mapping function. And next one is initial state. Next tuple is initial state, which means Q naught. So Q naught is the initial state. Again, in this diagram, we are here also, we are having the initial status Q naught. So initial state equal to Q naught. Okay. The next one, the F is final state. So F represents the final state. So in transition diagrams, the final state will be marked by using this double circle. Okay. So the double circle means that states are called as final state. So in this diagram, the final state is Q2. So this is the example of finite automata, which means in finite automata, we should have the 5 tuples. So 5 tuples means Q, sigma, delta, Q naught and F. So this is the example of finite automata. Next, we will move on to the next one, which means the types of finite automata. So here we are having two types. One is DFA and another one is NFA. DFA means deterministic finite automata. And NFA means non-deterministic finite automata. So in DFA, there is a difference between DFA and NFA. So in DFA, each state, which means in DFA, each state should be read by the input symbol. Okay, and in NFA, there is no need to read all the input symbols in the states. Okay, and again another one difference is in DFA, by using a single input, we should travel, which means we should the transition should be done by one state to another state. But in NFA, by using single input, the transition is done more than one state. That is the major difference between DFA and NFA. So we will see one example. So here you can see, so here we are having the initial state at S0 and we are having the final state as S2. Okay. So as I told, in DFA, all the states should read all the inputs, right? So here we are having the input as A and B, right? So in this diagram, the transition is done by using the input symbol A, S0 to S1. There is one transition. Okay. Another one transition, which means we are having the B input symbol, but there is no transition from initial state to final state. So that we are considering that transition as dead state. So we are considering that transition as dead state. Okay. And then next we are having another one state, which means S2. In S2 we are having the two input symbols, which means A comma B, which means S2 while reading A, it will start from S2 and it will end with S2. Again we are having another one input, which means in S2 we will start with S2 by using the input symbol B. Again we will end with S2. Okay. So this one is called as loop, self loop, self loop transition. Okay. In NFA, here also we are having the initial state as S0 and we are having the final state as S2. So here we are having the S0. So by using the input symbol A, we are having the transition from S0 to S2. At the same time, by using the symbol input symbol B, we are having the transition from S0 to S0. At the same time, S0 to S2, which means by using the same input symbol, we have more than one transition function. So this is the major difference between NFA and DFA. Okay. Then next we will move on to the conversion. Conversions. So here we are having three conversions, which means NFA. Second conversion is NFA with epsilon to DFA. Third conversion is NFA with epsilon to NFA without epsilon. Let's see the conversions one by one. First conversion, conversion of NFA to DFA. So example, so in this example, we are having the NFA transition diagram. So why? Because this is called NFA diagram means here we are having the input symbols. So first we should check whether the transition diagram is FA, which means finite automata or not, right? So first we will check whether this transition diagram is, which means this automata is a finite automata or not, right? So as we learned, finite automata should satisfy 5 tuples, right? So first thing is Q. Q means finite number of states. So in this example, so here we are having finite number of states, which means Q0, Q1 and Q2. And next tuple is input symbol. So input symbol, we are having two input symbols, 0, 1, and next one is transition. So here is a transition is there, right? So this is one transition and this is one transition and this is another one transition. So a transition is available here, which means transition is there. Okay. The next one is initial state. So initial state means here we are having the initial state as Q naught. So Q naught is the initial state. The next final state means when the states are marked as double circle, then the states are called as final state, right? So F tends to Q2, which means Q2 is a final state. So this automata is a finite automata, right? So next we should check whether this finite automata is a NFA or DFA, because we are going to convert this NFA to DFA. So we will check. So here we are having the states and the input symbols, right? So we will consider the initial state as Q naught, which means we are in the state of Q naught. So while reading this 0 input, the transition is done between the loop, right? So Q naught reading the input symbol 0 and it will reach Q naught. Okay. The next again we are having the input symbol as 1, right? So we are in the state of Q naught. So Q naught we will read the input symbol 1 and we will move on to the new state, which means next state is Q naught. Again we will move on to the Q naught. Again we are having another one transition by using the same input symbols, which means Q naught again reading the input symbol 1 and it will move on to the state as Q1. So that is why this transition is called as NFA. Okay. Okay. So how to convert the NFA to DFA? Okay. So first step is we should consider the initial state as a new state. Okay. So here we are having the initial state as Q naught. So consider first step, consider initial state as new state, which means Q naught is a new state. We can mark this as 1, new state of 1. Okay. Then next, construct transition table. Transition table of this NFA. So transition table represents the table format of the transitions. Okay. So this column represents the states and this column represents the inputs. So here we are having the input as 0 and 1 and we are having the state as Q naught, Q1, Q2. So Q naught, Q1 and Q2. Okay. So this is the transition table. Okay. So here to fill this transition table, we have to see the transition functions. Okay. So here, this one represents the initial state, so that we are marking this as an arrow mark, and Q2 is a final state, so that we will mark this as a star symbol. Okay. So we are in the state of Q naught, right? So we are in the state of Q naught. By Q naught, while reading the 0 input, it will move on to the which state. Okay. So which means Q naught, which is reading the input symbol 0 and it will move on to the which state, which means the final state. So here we are in the state of Q naught. It read the input symbol 0 and it will move on to the state Q naught. So that Q naught is fill in this column. Okay. The next one is again we are in the state of Q naught. it will read the input symbol 1 and it will move on to the which state. Okay. So here we are in the state of Q naught. It will read the input symbol 1 and it will move on to the which state, which means here we are having the transition, which means we are having more than one transition by using the same input symbol, right? So we are reading the input 1 and it will move on to two states, right? One is Q naught and another one is Q1. So that we will mark this as Q naught comma Q1. Okay. The next one is the same thing we will follow for the rest of the states. Okay. Next is Q1. So we are in the state of Q1. Okay. So we are in the state of Q1. So in Q1 we are reading the input symbol 0 and it will move on to the new state Q2. So we are Q1 reading the input symbol 0 and it will move on to the state Q2, right? Again we are in the state of Q1. So by reading the input symbol 1, we will move on to the next state, which means again Q2, right? The next we are in the state of final state, right? So in final state, there is no transition, right? So as I told, there is no need in NFA. It is not necessary, which means all the states should read all the input. That is not necessary in NFA. Okay. So here there is no transition in by using this input symbols zeros and ones. So we are mentioned this as a pi. Pi means there is no transition. Okay. So this is what the second step, which means construct the transition table. Okay. Then next step is we should find the transition functions for the new states. Okay, we should find the transition functions for the new states. Okay, so third step is find transition function. So here already we are having the new state 1 as initial state, right? So we are having Q naught as a new state 1. So we will start with this new state, which means transition of Q naught comma 0. Okay, transition of Q naught comma 0, because we are having the transition function. To find the transition functions, we need the old state and the input symbol and the new state, right? So here we are having the initial state as Q naught and we are having the input symbol as 0. So the transition should be Q naught 0, which means it will move on to the new state Q naught. Okay. So Q naught is already we will consider this. We have considered this as a new state. So leave this as it is. Okay. Next transition is transition function of Q naught comma 1, which means we are moving to the next input symbol. Okay. So while reading the input 1, so we are getting the transition state. Next state is Q naught comma Q1, right? So Q naught comma Q1. So this Q naught Q1 is a new state, right? So here we can consider this as a new state 2. Okay. So to differentiate this as a new state, we will mark this delta dash, which means transition function dash of Q naught comma 1. Instead of this curly bracket, we should mark this as a box bracket. Okay. So Q naught comma Q1, and we should mark this as a new state of 2. Okay. So we find the transition function for this new state. So we already found. So next we will move on to the transition function for the new state. Okay. So here our new state is Q naught comma Q1. Okay. So we should find that new transition function for this new state. Okay. So transition function of Q naught comma Q1. Again we are having the input symbol as 0, right? So here we are having two states combined together and we will consider this as a one state. Okay. So while finding the transition function, we can write this as a transition function of q naught comma 0 union transition function of q1 comma 0. Okay, so here we are to find this combined state, we are splitting the states into two, okay, by using the symbol union. Okay, so now we should find transition of q naught comma 0. So transition of q naught comma 0, again q naught, right? So q naught union transition of q1 comma 0. So transition of q1 comma 0 means q2, q2. Okay, so here we are having q1 comma q2. Okay, so in previous states, in new state 1 we are having q naught, and in new state 2 we are having q naught and q1, but here we got the state as q naught comma q2, so that we can consider this as an again new state. Okay, so to differentiate this, we will mark this as a transition function of q naught comma q1 comma 0 equal to, in this box bracket we should write q naught comma q2 and mark this as a new state 3. Okay, so we found the new state, we found the transition function for this new state by using the input symbol 0. Okay, next we should find the transition function by using the input symbol 1. Okay, so transition of q naught comma q1, input symbol is 1. So here also we should write transition function of q naught comma 1 union transition of q1 comma 1, right? So transition of q naught comma 1. So transition of q naught comma 1, we are having q naught q1, right? So we are having the status q naught q1 union transition function of q1 comma 1. Of q1 status q2. Okay, so while combined together we will get the status q1 comma q0 comma q1 comma q2. Again this is a new state, right? So that we will consider this as a new state. So to differentiate this, delta dash of q0 comma q1 comma 1 equal to, within box bracket we should write q0 comma q1 comma q2 and mark this as a new state 4. Okay, so we have completed the transition for this new state 2. Okay, next we will find the transition function for this new state 3. Okay, so transition function of q0 comma, the new state is q0 comma q2. So q0 comma q2, the input symbol is 0. So here we will write transition function of q0 comma 0 union transition function of q2 comma 0. So transition function of q0 comma 0. So transition function of q0 comma 0 means we will get q0. Okay, so here we will get q0 union transition of q2 comma 0. So q2 comma 0 means there is no transition. Okay, so pi. So finally we will get the status q0. So q0 is already, it's marked as a new state of 1. Okay, so leave this as it is. Okay, the next one is transition function of q0 comma q2 comma 1. Okay, so we can write transition function of q0 comma 1 union transition function of q2 comma 1. Okay, so transition function of q0 comma 1. So transition function of q0 comma 1, we are having q0 q1, right? So q0 comma q1 union transition of q2 comma 1. So q2 comma 1 means q2 comma 1, again there is no transition, which means 5, right? Okay, so finally we will get q0 comma q1. So we will check this state with the previous states, right? So q0 comma q1. So q0 comma q1 means already we mark this as a new state 2. So that leave this as it is. Okay. So we have completed the transition. We have completed to finding the transition function for the new state 3, right? q0 q2. Now we have to find the transition function for this new state 4. Okay. So transition function of new state 4 means q0 q1 q2, right? So q0 q1 q2 comma 0. So here we can write this as a transition function of q0 comma 0 union transition function of q1 comma 0 union transition function of q2 comma 0. Okay, so transition function of q0 comma 0. Okay, so q0 comma 0 means q0 comma 0 q0, right? So q0 and q1 comma 0. So q1 comma 0 means q2. Okay, so q union q2 union q2 comma 0. So q2 comma 0 means there is no transition, which means 5. So finally we will get q0 comma q2. Now we will check this states with the previous states. Okay, so q0 q2, so which means already we are having this q0 to q2 as a new state 3. Okay, so that leave this as it is. Okay, the next we will move on to the next input symbols, next transition, which means by using the input symbol 1. Okay, so transition function of q0 comma q1 comma q2 comma 1. Okay, so transition function of q0 comma 1 union transition function of q1 comma 1 union transition function of q2 comma 1. Okay, so transition function of q0 comma 1. So q0 comma 1 means we will get q0 q1. So transition of q0 comma 1 means q0 q1 union transition function of q1 comma 1. q1 comma 1. So q1 comma 1 means q2, right? So q2 union transition function of q2 comma 1. So q2 comma 1 means q2 comma 1. So q2 comma 1 means there is no transition, which means 5, right? So finally we will get the states as q0 q1 and q2. Now we will check this states with the previous state. So while checking, we will found that this state is again already we have found as a new state 4. Okay, so leave this as it is. Okay, then next this is the third step. Okay, which means to find the transition function for each new states. Okay, then final state is fourth state is construct the transition table. Construct the transition table for DFA. Okay. So now in this DFA, we will consider the states as what are the states we have found as a new states. Okay, those states are finally consider the states for the DFA. Okay, so the first state is new state is Q naught. So new state 1 is Q naught. So then next state is Q naught Q1. This is second state, and third state is Q naught Q2. And fourth state is Q naught Q1 Q2. So these are the new states. Okay, so here we can consider this and this as a final state because these two states are having the final states Q0 Q2, right? So that we can consider these two as the final states. Okay, now we will fill this transition table. So here we are in the state of Q0. So by using the 0 input symbol, the Q0 is moving to one state to another state, which means from Q naught, by read the input symbol 0, it will move on to the state Q naught, right? So here we can fill this Q naught. Okay, next is Q naught 1, which means Q naught 1. So Q naught 1, it will move on to Q1 Q1, Q naught Q1. Okay, so here Q naught comma Q1. Okay, next Q naught Q1. So Q naught Q1 reading the input symbol 0 and it will move on to the states Q naught Q2. Q naught comma Q2. Okay. The next again this Q naught Q1 reading the input symbol 1 and it will move on to the state Q naught Q1 Q2. Right. So here Q naught Q1 and Q2. Okay. Next Q naught Q2. So Q naught Q2 reading the input symbol 0, it will move on to the state Q naught. And next one is Q naught Q2 reading the input symbol 1 and it will move on to Q naught Q1. Q naught comma Q1. Okay. Next Q naught Q1 Q2. So Q naught Q1 Q2 reading the input symbol 0 and it will move on to the state Q naught Q2. So Q naught comma Q2. And next this Q naught Q1 Q2 reading the input symbol 1 and it will move on to the state Q naught Q1 Q2. Q1 and Q2. So this is what the transition table for DFA. And the final step is transition diagram. Okay. So here we are having the states, 4 states. Q naught is a one state and Q naught Q1 is another one state. Q naught Q2 is another one state. Q naught Q1 Q2 is another one state, right? So we should write all the states. So Q naught is the initial state and Q naught Q1. So Q naught Q1 is a another one state, and next one is Q0, Q2. So Q0 comma Q2 is another one state, and finally we are having Q0, Q1, Q2. So Q0, Q1, Q2 is a another state. So while putting the transitions, we can see Q0 0. So Q0 state reading the input symbol 0 and it will move on to Q0. So that self loop 0, right? Next Q0, Q0 it will read the input symbol 1 and it will move on to the state Q0, Q1. So from Q0, by reading the input symbol, we will move on to the next state Q0, Q1. Okay. Next here Q0, Q1. Q0, Q1 reading the input symbol 0 and it will move on to the state Q0, Q2. So 0. And next again Q0, Q1 reading the input symbol 1 and it will move on to the state Q0, Q1, Q2. So here Q0, Q1, Q2. Okay. Next Q0, Q2 reading the input symbol 0 and it will move on to the state Q0. So it reading the input symbol 0 and it will move on to the state Q0. Okay. Next Q0, Q2 reading the input symbol 1 and it will move on to the state Q0, Q1. So Q0, Q1. And next one is Q0, Q1, Q2 reading the input symbol 0 and it will move on to the state Q0, Q2. So Q0, Q2, so 0. And Q0, Q1, Q2 reading the input symbol 1 and it will move on to the state Q0, Q1, Q2. So this is the final DFA. So that we are converting the NFA to DFA.